How's it going? This is the bike frame fatigue testing stand. Our project is sponsored by Equinox Bicycle Works and Engineering LLC, Houghton company located over here in the UP, so it's definitely at home for us. And this department project is through the manufacturing and mechanical engineering department. And we'll get into a little bit about the project team. The project team started on the left-hand side. Hi, my name is Joseph Williams. My primary role on the team was controls and pneumatic systems, and also customer relations. And I'll pass it off to Mike.
Hello, my name's Mike Forrester. I did a lot of manufacturing on this project, as well as doing the mechanical component design for both of our test fixtures.
My name is Robert Sullivan. I was in charge of the quality assurance and the manufacturing processes.
And on the far right, my name is Brandon Kuhn, and I was in charge of FEA and mechanical design analysis.
The main goal of this project is to create a bicycle test frame fixture for use in testing the custom bike frames created by Equinox Bicycle Works. In order to do this, we use the ISO 4210 standard. The 4210 standard involves a horizontal test with forces moving horizontally, a vertical test with forces pulling down from the seat stem, and a pedaling test with 2 forces on each of the pedaling fixtures. The objective of this project is to create a test frame because in order to prevent a failure while operating, which could cause a injury to the operator, it is also in Equinox Bicycle Works' main motive to create a sturdy bike frame.
As you can see here, these are both of our test fixtures. The frame on the left incorporates both the horizontal and vertical frame. For the horizontal test, we have a pneumatic cylinder pushing against the front fork clamp on the bike. And for the vertical test, we have a pneumatic cylinder pulling down on the seat post. On the right, this is our pedaling frame. This one is easier to visualize as a bike being mounted on there. This is to simulate someone pushing down on the pedals and transferring the weight throughout the frame.
Moving on a little bit to the electrical, obviously with this system, you have to record some data, displacements, and all that great stuff. So with this project, we used a Click PLC. We obviously have discrete inputs and outputs for buttons and outputs for the solenoid valve packs. Also some analog inputs for the sensors. Obviously, we're using force sensors and displacement sensors, also incoming pressure sensors as well. The system uses 124 volts AC and converts it over to 24 volts DC. And directly related to that, this also has pneumatics design. So we actually have incoming pressure of 120 PSI and a working pressure between 10 and 80 PSI to control the valves for forces.
Looking at some of the manufacturing issues we ran into along the way, we had some issues when it came to the fact that our project is in metric. So finding some taps and some other utensils and stuff was a little difficult. Along with that, we did not have any welding experience. So we had Bob volunteer and learn along the way. And lastly, we had some plasma cutting done for some of our parts, and the plasma cutter wasn't cutting exactly straight, so we had to go over a lot of our parts again with the mill and make sure everything fit just right.
So to conclude this project, obviously this is a currently ongoing project. We are still procuring items, also doing some machining, but definitely going to be completed by the end of the semester. There's one thing that we would like to bring up is obviously with computer chips and circuit boards and all that. We made some recommendations for the customer that we've agreed to finish this project, making work instructions for them when those delivery components come in. And the team's really excited to have been part of this project. Obviously, we implemented a lot of aspects of engineering, from controls to pneumatics to electrical, also mechanical considerations. I think the biggest thing is to everyone that was part of the manufacturing of this product was, definitely a time sake, but we also learned a lot. Definitely have to say great job to the whole entire team, and thank the project sponsor for being super involved. And his time is definitely a great investment in this project and educate us a lot on the industry as well. And just some of our acknowledgements as well, Brian Egghart, the president of Equinox Bicycle Works and Engineering LLC, our advisor, Kevin Johnson, and then some of the other individuals that we worked with a lot, Dr. Dave Labiak, Dr. Walness, Dr. Irwin, Nick Henderson, the machine shop operator, Pammy Swazowski, Mark Gauthier at Donald Engineering, and also Cleveland Cliffs for their financial support towards the project. Thank you very much.